My friends, welcome to my channel. As you know, we just crossed video 30 on my current 200 3D model series. At this point of the progression of this series, I believe it's a time to have a talk about topological naming issue, part versus part design. Where do I want to do my mirroring? Do I need to use the draft workbench? And why I am using Lattice 2 so much. So these are the issues briefly I will describe today. And let's go ahead and start with topological naming issue. The topological naming issue is, well, it's hard to describe. So let's go ahead and actually show it to you what the topological naming issue is. For example, let's start a sketch, very simple sketch. I'm going to say a circle of radius, for example 50. We got this sketch done. I want to rename that as sketch say base. That's what I always do, rename the first sketch as our base. And say I wanted to have a rectangular hole somewhere here on the upper side, right? So the hole is there, we drew it within the sketch, and then I want to make pad out of it. So extrusion, say 25 millimeter. And then I wanted to build another step right in front of this hole. So what I do, I select this surface, this face, and then I say draw another sketch on top of that face. So I say plane face, attach it to the plane face. This is what it is called mapping. So I mapped the new sketch that I'm drawing with the previous object. So I want to draw, say, this object on top of that surface. So now instead of this sketch being at this bottom at the origin, the elevation is at the same elevation as the surface of the object. I'm gonna go ahead and rename that sketch as sketch step. Say that's our second, and I want to pull that up by another 10 millimeter. So what I have now is I have this hole, there is this object with the hole, and then there is this step in front of it. If I wanted to do something at this level, say I wanted to have a floating step, so what I would do, I would come, select this face and draw another sketch. So I'm mapping another sketch on top of this object, and I want to have this floating tool kind of thing on here, right? And that sketch, I'm going to say rename that as sketch floating. Okay, let's go ahead and then pull that up by 25, right there. So we got this complex model where I have a pad, there is a hole, there is a step attached to it, and there is a floating object. At this point, I thought, no, I should have had another hole in front of here. So somebody comes up this hole, takes on this step and here, and then goes down all the way down. So I wanted to have another hole in the main base pad here. I can do that two ways. I can draw a hole, I can make a rectangular extrude here, make a cut, or I can go back to my first extrude and say, no, there should be a hole right here. I forgot about it, but now that I remember, let me come back and correct it. So that should be okay, right? Because the FreeCAD is parametric. Well, let's see. Did you see what happened? So we have had this hole, and there is this one step and one floating up step. It was not there. We wanted to have that hole there. Now the hole is there. But what happened to our two steps? Oh, one is there. So I see one of them is here. How about the other one? Where is this one? So this one is there, and this is, it's kind of in the middle. So the point is the object, the model is messed up. This should have not happened, and that's why it is called an issue, a topological naming issue. The issue is the name of this phase got changed, and this and that, and then the output is our object got screwed. Now the developers know about this, and then they've been working day and night removing this problem from the software totally, which may take a while. They are also working on some of the workbench stuff, how we can make that more flexible for user friendly for the users. But until then, we will have to have some safeguard in our modeling, in our sketching, where the topological naming issue should have not happened in our object. So that's what I will do today. I will discuss how we can do complex models without having fear of this topological naming issue. All right, so what I want to do, I want to open up a new file, and let's start from the scratch. I wanted to have a circle, like a circular pad, big enough, right? And then what I had to do, I had a hole, a rectangular hole at the upper side, and then I pulled it up by 25. That's our object. And then I wanted to have a step in front of this hole. So the best practice to avoid the topological naming issue is to not to map any sketch on top of any other objects. So do not select on this face and then draw on plain face. No, what we want to do is I want to offset this sketch. So I want to do it on the plane organic XY plane, and then offset this stage, offset the sketch by 20 millimeter. 20 millimeter being the height of this object. Was it 20? No, it was 25. So let's go ahead and then correct that. So here on the Z direction, so it's in the properties base group, under placement in position in Z direction, I say 25, right? And there, so it's on the surface. Now I can draw that step in front of the hole and make that up by say 25. Too much. 15. Yes. All right, now what I want to do, I want to draw this floating object, right? So the floating would be, so this is 15 plus 20. So this was the height of this pad and height of this pad, and draw that sketch. I got that wrong again. So you have to remember, this is 25, this is 15, so this should be 25 plus 15. All right, there, we got it right. So I wanted to have this floating pad in front of it, right? And then pull it up by say 10. So we got our object. At this point, we come back to make another hole in the main extrude, and so let's go back and draw that hole here. Okay, the object is there. So in the previously, when we drew this hole in the main sketch, we updated the sketch, not the dimension though. We added a new feature in the sketch, going back retrospectively. That messed up our model, but in a new way where we did not map anything on the surface of any object. The object is standing even if we went back and then updated things. So that's one way to do it. Now if you are doing one object and then it's one and done, this is great, we can do that. But let me actually say, now I wanted to have this 25 actually as 20. So I come back and then update this extrude property to 20. Let's see what happens. So that extrude went down, but this attached step, which is supposed to be attaching with this, like at the same surface level, now both of them became floating. Now I did not want this one to be floating. This is enough for floating. Now it is floating too. So this is unintentional, but it's there. So there is that thing that we have to take care of. So only going into the sketch and then updating this one, say making it 20, that helps. And then we'll have to come back and update this one too, which is kind of impractical. It doesn't make sense. Another way to do the same thing without this not making sense stuff is to put the values inside in the sketch via formula. Okay, so let's talk about formula and applying how we can apply formula in our sketching. So this sketch, it has some parameters, right? And there are some constraints that I have not put in. So let's go ahead and then put in some constraints. In this one, I'm going to say this is 50. Okay, so that's our one constraint. Now we select this sketch and come here in the constraints. You can see the constraint says 50. I can update that here, make it 45. That changes 50. So we don't have to go into the sketch to update the constraints. We can do it from this data tab. So we now know that. Select the extrude, right? It also has some data properties here. Look at this length forward, which is the value that we put in to make this extrude. We can make that 25. It moves. We can go back to 20. So this name is important, length forward. Let's remember that name, length forward. Come to this sketch, right? And here in the position and in the Z direction, that's where we put the offset in. I want to click on this FX button and this enter an expression. And here I want to say, I want to make this 20 related to that extrude height, this length forward. So what I want to do is I want to say write in extrude, it came in, dot length forward. Remember that length forward, there is no space in between. The formula doesn't handle spaces real good. So try avoiding spaces. So we say extrude.length forward, that pulls in the result in there. I said hit OK, right? Now every time I go change this 25, this object moved too. So I make it 15. So both of these are acting at unison. So that is what the formula does. You click on, you set the formula in there, everything moves up and down at the same time. So we did take care of this one. And then this height is 15, right? So that's also length forward, but that's under extrude 001. So let's come and then fix this case. That height would be in the placement here. I want to say it would be height of this extrude. So extrude dot length forward plus, and now I also want to add this extrude. So hover over the mouse on this name and then it will show on the screen. And here, let me actually try this new feature that I installed. So here I want to say extrude 001. 001, it's there, right? Dot. And then I want to say length forward. So I'm adding both of these length of this extrusion, right? And hit OK. Now what happens is every time I change this to 20, all the connected objects moves with it. I can make it 15, both of them moves. Let's see. From this side, it may be better. So make it 20, everything moves. 25 moves. I can come here, change this extrude. I can say this is 35. So anything related to that one goes up and down too. We can also take references between like from the sketch. So let's go in this sketch and say this height, I'm going to put some height in it. I'm going to say 20, right? And then what I want to do, I want to make this height, so this object, as high as the length of this sketch. So if I wanted to do this relation, say I want to make this third step as tall as the width or like the length of this second sketch, I can do that. To do that, I'll have to put a name to this 20, this dimension. So I want to say name length 2 from the second sketch. All right, I put the name in there. It says name optional, so without the name the sketch work, but we need this name for referencing. So all right, so we put the name in there. It's under sketch 001. Now it's not under extrude, it's in the sketch 001. Now come here, this extrusion length forward, we can say we want to make that. So take sketch 001, that's the one, and then say constraints. So that's part of the formula, and now I can hit anything and then it will show me all the constraints there, length, or I can say length, and it comes in as 20 millimeter. All right, so now every time I go click on this constraint and say make it 25. Okay, remember this, that the name that we put in length 2, it's here. I can make it 25, right? This height changes too. So that's another thing about sketching. Going forward, like in the next videos in this 200 model series, I'll be using these features more and more. So where I'll be expressing formula and using linking adds and stuff between them. So I wanted to have that talk here. So that's how one way to actually handle topological naming issue, and also using formulas to make our sketching better. Now, had we have a spreadsheet in our value, say length. So on the spreadsheet, I discussed that in the past, we can have length value in the spreadsheet and come here, put an alias length 2, and then we can use that length in our sketching as well. So I can say spreadsheet dot length 2. Now what happens is we can go to the spreadsheet, right? I want to discard this. Yeah, I don't want that. I can go place it side by side. So we can go to the spreadsheet, change it to 25. Our value still rocks. Our spreadsheet works. So the formula is the height of this object will be length of this object, and I can pull that length from a spreadsheet. So if I use spreadsheet, that's also we can pull all the data from the spreadsheet. So there are like using spreadsheet to enter values. There are avoiding, so all of these to avoid topological naming issue. And topological naming issue is the thing when we map a surface and a sketch to a surface, and that's what we want to avoid. We want to avoid mapping a surface, mapping a sketch on a surface at any cost. I hope that is clear to you all. So that's topological naming issue. Let's pray that it will be solved in near future, but until then we want to avoid that, and this is the ways to do it. All right, let's talk about workbenches. I specifically want to express my thought process on part design and Ltis 2 workbenches. Ltis 2, okay, let's talk about part design. You have seen me using part design on and off, but mostly I have seen me using part workbench throughout like last for all the videos that like I have used part workbench for 90% of my videos. Why is that? The one thing I love about Part Workbench is the flexibility it offers in creating the objects. Like I come here, create a sketch and then models. These models can be floating like this. I could create this model without any attachment to the origin or any other object. Now in part design, that's a problem. First of all, part design cannot work outside a body. So we'd have to have a body, must. Then I can have sketch in it, and sketch has to be on any other plane, so that's okay. That's nothing new. And then let's say I wanted to have this rectangle, all right? So let me actually hide these three for now. So this object, I'm making it safe 25. There, I made this object. I wanted to have a floating stair right next to it. So let's go ahead and let's follow the required best practices to avoid topological naming issue. I'm going to go ahead and then create a sketch on XY plane, right? And close it and then go back to actually change the attachment and say on this one, I'm going to say pad dot, and what would be, so pad, was it length forward? I'm going to say length 25. So for pad, the parameter is length. That this one, now I can come and like I did in part workbench, I can create floating stair there and make a pad out of it, say 25. See, it says result has multiple solids that is not currently supported. Well, that's a cryptic message. What it says is you cannot do that. I cannot make a floating object in part design, which limits my ability, and that's one of the main reasons I don't start anything in part design. I could come back to it sometimes. I don't start it in part design, which may change, but anyway, so let's go ahead and then update this sketch to make it overlapping with the main object. And now let's see, make a pad of 25. We can do that. So this is one thing that bothers me too much. Like, why would I not be able to do that? Why does it have to be connected? What if I wanted to have two different horns of a bull, say, and the part design says no, that bull doesn't fly here. So that was the one thing why I got more into part workbench, where it actually allows me to be flexible in placement of objects. So that's a minor issue. Now that I know it's there, I can avoid that. So another thing is Boolean operation. Part workbench allows me to do Boolean and then go back and find that object and then Boolean it 3 more times. The Boolean operation, this connect tool, these are pretty awesome in part workbench. Part design, it does have Boolean built into it. So say if I had, okay, so in Boolean, part is good and bad. Part design is like, you know, it's flexible, but there are issues. Say I wanted to make a hole in there. In part, it would be 2 extra steps, but in part design, just come here and then, so what I want to do is actually, I want to create a sketch on XY plane, right? And then I want to make, say, this circular area. What would be the hole in here? So, and then I say, I want to make a hole in this step. I create this sketch, make it reversed, make it through all. There it is. The hole is there. Now, if it was in part, I would have to make a cylinder and then make a Boolean operation. So the Boolean is built into part design workbench, which is good. Sometimes it's bad, but it's good in general. So it's always Boolean joining thing in part design, where in part it keeps things separate for me to actually use it to my advantage. So Boolean is kind of in part design is kind of mixed feeling for me, and that's also one thing, like I'd like to have my freedom on Booleaning in part workbench. So when it comes to Boolean, it's user friendly in part design, but I like part better. I would like to like have them as I wanted, like I can go back and then pick my cherry and make them Boolean later on. So part design allows that, but it's a little complicated. I won't get into that. The other thing is mirroring. Now mirroring is the best thing that could offer part design could offer. Part mirror tool is very limited. It's easy, but it's very limited. For example, part, if I wanted to mirror this, right, the mirror plane is limited to 3 planes, x, y, y, z, and xz plane. The standard mirrors, like I could do, for example, I could take this object, which is extrude 2, and mirror it against any of the standard planes, but I could not mirror that against this plane. So there is no way I can mirror this against this custom plane in part workbench. But in part design, I can do a lot of things when it comes to mirroring in part design. For example, so this was the pad, the first pad, this is the second pad, this is the pocket, right? What I want to do, I want to take this pocket and mirror it in here too against this face. Let's see if I can do that. All right, so in part design, I can come and say select pocket and come here in mirror, right? And in the plane, it has multiple options. So base planes, and then it says select reference, which is awesome. I want to come and select this face, and there. So this is my hole, which is a subtractive feature, and then it has been replicated, mirrored against this plane, custom plane that I selected. So if there is one thing, if you asked me what is the best thing in part design, this is the best thing in part design that I cannot get from any other workbenches. So there is a mirror option in draft workbench, but draft workbench is meant for 2D drawing only. So if I wanted to have this thing in draft, it should not be that intuitive. It would be like more. So draft I don't need. We need draft for modeling. Sometimes it can help. But draft is more for 2-dimensional drawings. Sometimes it helps, and we'll get into that in some more advanced features. But for now, we can use FreeCAD to our full potential without using the draft workbench. Okay, let's get back to part design, where I wanted to say mirroring is the best in part design. So that's the best feature that a part design workbench can offer. Let's talk a little bit about Lattice 2 workbench. So Lattice 2, some of you all have not mentioned that the polar array, this linear array, all these arrays are available in other workbenches. For example, part design have them readily available. I really loved it that part design has it readily available. So if I'm using part design for mirroring options and any other options, I will definitely use that the polar array, polar pattern, and multi-transform. These features, these are like really great in part design. But since I can get that from Lattice 2, and Lattice 2 has multiple other options, mirror 2. So mirror actually in Lattice 2 is also a powerful tool. So I tried that one time, and then I really liked it. So if I have anything started working in part workbench, and then I find out that I should have done it in part design just because of mirror, I can come here and then do the same thing with some additional steps. So Lattice 2, in summary, has a lot more options for me to grow into in future days. So I wanted to start it when I'm fresh. So I would love you to do the same thing. So Lattice, and that's why I keep coming back to Lattice 2, where I can actually get familiarized with this workbench, because it has so many potential for us to actually grow into. And that's the reason I don't go to draft. I'd rather go to Lattice 2 and then work on it. So I'll see you in the next video. I hope you enjoyed this video. Thank you for watching. Bye.